start with chapter 1, which is Introduction to Networking. Before I start, the comment section are open, so if I say something wrong, like mention the minute and the second and correct anything that you think I said it's wrong. Uh, Also, if you have more information or something you can elaborate, like also mention the minute and the second, and elaborate more so the other can benefit from your knowledge. Uh, what else? These slides are like the credit goes for the KFUPM University, of course, so the slides won't be shared. I guess that's it. Let's begin. The objectives is to introduction to data communication, introduction to networks, introduction to the internet, and protocols and standards. First of all, the term telecommunication, which includes telephony, telegraphy, and television, means communication at a distance. It's like a tele is a Greek, like it means far. The term telecommunication means a communication at a distance. The data refers to the information uh, presented in whatever form is agreed upon by the parties creating and using the data. And of course, data communications are, we mean by it like exchange the data between two devices via some form of transmission media, such as wire, cable, or wireless. Like exchange data, usually between two devices, and via some transmission medium like wire or cable, etc. The five components of data communication is the message, sender and receiver, the medium, and the protocol. We mean by the message, the information that we want to send, the data to be communicated, sender and receiver like device 1 and device 2. The medium is the way that we are sharing. Is it a cable? Is it a wire? And so on. Transmission media, it's a physical path, the physical path. It can be twisted pair, cable, fiber optic cable, or radio waves, etc. The protocol, we mean by it like it's the rules that two parties agree on so that they can share communication. They can share the message, I mean, smoothly. So it's a set of rules. Okay, effectiveness of data communication. Uh, the effectiveness or how to measure the efficiency or the effectiveness of the data. We have these four criteria, like the delivery, the data to deliver data to the correct destination. Like if I want to send this message to Faisal, it must be arrive to Faisal, not to Omar. The accuracy, deliver the data accurately. So why it's mentioned like accurately? Because we have sometimes noise. The noise can affect the accuracy of the data, of course. Timeless, like it should be arrived in timely manner. We don't want it to be like late too much or something. The jitter, the jitter we mean variation in packet arrival time. Like for example, if you want to send something to another device, it will be, uh, distributed or it will be split it in packets. Each packets will arrive in different time. Like the first packet will arrive in 3 seconds, the second packet will arrive in 5 seconds, and so on. So we will have variation in timing in each packet. So that's what we mean by jitter. Okay, data flow. We have three main types of transmission circuits. The first one is simplex mode. The communication is indirectional as on a one-way street. Like indirectional, we mean like it's only one way. It can't be like from right to left, just from left to right. And here an example is a monitor. The monitor cannot give data back to the to the PC, but the PC can give information to the monitor to let it show or display something. This is the first type of transmission circuit, simplex mode. The half duplex mode, both parties can send data from one to another, but only one at a time. Like if the station one want to send something to station two cannot at the same time send something to the station one. So each one of them will only share data at once. But in the last transmission circuit, which is a full duplex mode, both can send to each other and at the same time. So both of them can send the data simultaneously. Okay. Example. Okay. We have the keyboard. It's an example of the simplex mode. We have the mouse. It's also an example of simplex mode. Traditional monitor, also simplex. It can't send data back. It just receive data. GPS device is a full duplex. It's received and also send data. Walkie-talkie, it's a half duplex. Telephone is a full duplex. All right. Network. A network is a set of devices, often referred as the nodes, connected by communication links. A node can be a computer, printer, or any other cable of sending and or receiving data. So usually you can imagine it like the network, like you have these circuits are devices, and they have links between each other. So I guess that's what they are trying to illustrate to us. Network criteria. We have a criteria, of course, of the network to make so that we can measure it. Networks must be able to meet a certain number of criteria. First of all, the performance. So we have the transit. The transit time is the amount of time required for a message to travel from one device to another. I guess it's clear. Response time is the elapsed time between the inquiry and the response. Depend upon number of users, type of transmission medium, capability of hardware, efficiency of software. So these are the factors that affect the response time. Reliability, which means measure the frequency of failure, time it takes a link to recover from a failure, network's robustness in catastrophe. Okay. Security, of course, protecting data from unauthorized access. Type of communication, we have two types, like point to point, which mean one device to another, and multi-point, which means one to many, or so on. Network topology. Topology of a network is a geometric representation of the relationship of all the links and linking devices nodes to one another. You can say like topology is like a way to represent the devices in a geometric representation for the devices. So we have four types: the mesh topology, the star topology, the bus topology, and the ring topology. And each of one has advantages and disadvantages. We're gonna take a deep look at them now. Uh, all right. Here in the mesh topology, each station is connecting to all other station. Like this station is connected to this and this and this and this, and same goes for each station of them. Here we have the bus topology. We have a cable, and here a tab and drop line for each station. It's look like a bus, of course. Here the star topology. All of them like communicate with each other via the hub. So they cannot communicate directly from one to another. They have to communicate with the hub, and the hub will make sure to send the data to the station. So all of them are communicate with the hub in order to communicate between each others. And the last one here is the ring, of course. The ring has a repeater, and we will now soon know why it has a repeater. So uh, let's start with the first one. It's mesh topology. Every device has a dedicated point-to-point link to every other device, as we said. Dedicated means that a link carries traffic only between the two devices it connects. Uh, Advantages: guaranteed load, robust privacy or security, fault identification and fault isolation is easier. Disadvantages: I/O ports installation is difficult, as shown. Expensive hardware, of course. More writing space, amount of cabling, and like it requires many cables, as you can see, and you can count the number of cables using this formula, which in mean the number of stations. Like here we have 1, 2, 3, 4, 5 stations, which mean 5 by 4 over 2, which mean we have 5 of 4, 20 over 2, we have 10 duplex links, duplex mode links. It's used usually at a backbone. The start topology: each device has a dedicated point-to-point link to a central controller, which is the hub. No direct connection or traffic. So as I said, no station can send to another station directly. It have to communicate via the hub. Advantages, of course: less expensive, one link and one I/O port, easy to install and reconfigure, less cabling but more than bus or ring. Node failure will not affect others. Fault identification is easier. Disadvantages: single bolt of failure, which means if the hub uh, like get something, all of them will be disconnected and can't communicate with each other. The bus topology: we have a multi-point, like one cable acts as a backbone to link off all devices in a network. As we can see, the cable, it's like have a multi-point so that more than one station can like drop a line in it. Drop a line, a connection running between the device and the main cable, as you can see. Uh, and the tab, a connector that either supplies into the main cable or punctuates the she the sheathing the sheathing of the cable to create contacts with the metallic core. Signal degrades due to energy being transformed into heat, so there is a limitation on the number of tabs allowed. Like the tab generates the heat, so maybe you can't have many tabs between each other, so it affects the number of tabs that we can have in one cable. Advantages: easy to install, less cabling. Disadvantages: limit on number of tabs and the distance between tabs, difficult to identify fault, signal degradation, and modification is difficult also. Ring topology: each device has a dedicated point-to-point connection only with the two devices on either side of it. Like this, for example, this station can also only communicate with this station or this station, or we mean to have it have a direct communication with it. Each device incorporates a repeater. This is a repeater, as you can see. For each device, it has a repeater. When devices receive a signal intended for another device, its repeater regenerates the bits and passes it along, which means if this station wants to communicate with this station at the end, it will go for the first station. The first station will know it's this data not intended for them. It will repeat via the repeater all the bits and etc. to another the station beside it, and the station beside it will see that it's not also meant for him, so it will repeat it via the repeater to the last station, and this how the data transfer from the first station to the last station. Some systems have a dual ring or switch cable of closing off the break. Advantages: easy to install, fault isolation is easier, signal circulates at all times, like alarm alerts the problem, and its isolation. Disadvantages: unidirectional traffic. In a simple ring, a break in a ring can disable the entire networks. Of course, it's clear. Like if the cable gets something, all of them will get disconnected. Hyper topology, well, which means like combining more than one type of topology at once. Like here we have a hub, here a bus, and here a star, I guess. Yes. Okay, and also here another type of high part. Like we have the star because we have a hub here, and also at the same time we have the bus. Yes. Categories of networks. We have three types of network. The local area network, which the abbreviation is LAN. Metropolitan area network, which the abbreviation is MAN. Wide area network, which is WAN. The differences between them, it's the size, ownership, distance it's covered, and the physical architecture. The LAN, first one of them. Privately only, so you can use it in the office or something. Links devices in a single office, building, or campus, limited to a few kilometers, sharing of resources, hardware, or data, use a single transmission media, and usually the topology for it is ring, bus, and star. And as you can see, it's like a simple single building line, which means these all devices are in one building or in one room, office, or etc. So it covers a small like area. An isolated LAN connecting 12 computers to a hub in a closet. Like it shows you like how it's isolated. The LAN, of course, might have here like a backbone. We can, like as we said here, it can have a ring, a bus, and a star. Here it show you the different type of them, and they can communicate with each other via a backbone. But as you can see, like each one of them is a small entity, so it's not that big. It's not. Does not cover like a wide range of distance or something. So it's a multi-building LAN. The MAN is wider than the LAN, of course. Uh, Here it says like we have a public city network, for example. So it extend over an entire city, not like the building or an office, owned and operated by a private company, service provider also. So here it showed like the city, for example, and here maybe a different building or neighbor, and so on. So it cover a wide uh, a wide distance, not like the LAN. One, of course, is the biggest one of them. It's cover over large geographic areas, so that may comprise a country, a continent, or even the whole world. So it's like a wide. One that is wholly owned and used by a single company is often referred to as an enterprise network. All right, switch one and point one. A switch one is a network with more than two ends. He mean here end by like this end system. Here we have three end system, so here we use switched one because we have more than two ends. A point-to-point one is a network connecting two communication devices to a transmission media. Like a point-to-point one when we have two entities only, so it's a point-to-point. Here it says if I have more than two, we will use the switched one, not point-to-point one. Heterogeneous network internetwork. Uh, I guess and it's an example that you like memorize. Like he said here, the definition: the heterogeneous network made of four ones. It made of four ones and two LANs. So where is the ones? Like here, for example, this is the first one. A second one, the second one. Here the third one, and here the fourth one. And here the LAN, the first LAN and the second LAN. So it's like when he says like identify or define the heterogeneous network, you will say it consists of four ones and two LANs, and as shown in the figure. The switching, we have an internet node, not the lowercase. which is the I, is a switch network in which a switch connects at least two links together. The switch forward the data from one network to another network when required. The two most common types of switch network are circuit switch network and packet switch networks, and we will know more about them now. The circuit switch networks, it has a dedicated connection called a circuit, and it's always available between the two end systems. That switch can only make it active or inactive. The packet switch networks, in a packet switch networks, the communication between the two networks is done in blocks of data called packets. It uses a router that has a queue that can store and forward the packets. The internet is two or more networks that can communicate with each other. The most notable internet is called the internet with the uppercase I, and is composed of thousands of interconnected networks. The internet consists of several backbones, provide networks and customer networks. The internet has revolutionized many aspects of our daily lives. It has affected the way we do business as well as the way we spend our leisure time. Okay, here it shows the hierarchical organization of the internet. So it starts from the we have the structural of the national ISP. So it starts with the ISP, normal ISP. Then we have here a router or a switch. Then regional ISP. Then national. So here is the wide ISP. Then here the smaller one, and here the smallest one of them. Or we have interconnections of national ISPs like different national. So. Um yeah, as shown, I guess there's nothing to explain here. Protocols and standards, as we said before, protocols like the rules, it's a set of rules that govern the data communications. A protocol defines what is communicated, how it's communicated, and when it's communicated. We have key elements in the of the protocols, like the important things of the protocol, of course, the syntax, structure and format of the data, how to read bits, like there is different rules, of course, of reading bits. Semantics, we mean the meaning of each section of bits. And of course, timing, which means refer to when to send the data and the speed of sending the data. Internet standards and drafts. A standard, it's a formalized regulation that must be followed. There is a strict produce by which a specification attain internet standards status. A specification begins as an internet draft with no official status and a 6-month lifetime. Upon recommendation from internet authorities, a draft might be published as a request for comment. A request for comment during its life falls into one of the 6 maturity levels: proposed standards, draft standard, internet standards, historic, and experimental, and informational. Of course, the standards request for a standard are classified into 5 requirements level. Maybe you should memorize it, like required, recommended, elective, limited, and not recommended. And of course, here we have the standard organizations. Maybe you can memorize or know their abbreviations. Uh, and I guess that's it for chapter 1. And of course, read the book for more information and clarifications.